Okay, welcome back. This is Chapter 4, and Chapter 4 is about Layer 3, the network layer. And if you're thinking, network? Haven't we been talking about network all along? Yeah, okay, so let's do a brief review. So the physical layer was all about electricity and things like that. It was all about taking some sort of piece of data, converting it into some sort of a signal, whether it be an optical signal or electrical signal or binary and analog, blah, 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 blah. It's all about taking data and putting it on a wire. I'm using the wire term kind of loosely here. That's what layer 1 was all about. Layer 2 was about just organizing the data, formatting it, so to speak, so that you could send it over the wire, and you could have some interesting stuff like destination and source and some sort of error checking. So formatting the data and kind of packaging it in a way to make it a little bit more robust. So that was its job. So you could say, well, okay, isn't that enough? I mean, you know, you've got data and you've got it organized with a destination and a source. Well, yeah, and you could kind of sort of stop at layer 2 if all you had was an isolated network just for you. But as soon as you want to talk to somebody else, you need a different type of thing to talk to different people. So that's what this is all about. This whole chapter is about routing. And so kind of the definition of routing is sort of like the fitting that goes between two different networks. So I have network over here and a network over here, and I want to join the two together. You do it with a router. Okay, cool. All right. The more classical term is routing has two parts. One of them is you chart the course, because it could be multiple paths to get from point A to point B. And then after you've charted the course, then you actually get there. Okay, so let's look at the learning objectives to make sure we got everything. So, what's the functions of the network layer? Heck, I've already told you what the functions of the network layer are. An overview of the most popular example of the network layer on the entire planet, which is the Internet Protocol. Yes, we're going to look at the IP header in some detail. Yes, we're going to be talking about IP addresses. Yes, we're going to be talking about the CIDR notation. I've heard that pronounced CIDR, and I've heard that pronounced CEDAR. I'm going to stick with CIDR. How do you go about getting an IP address? And then some changes that happened when we ended up with going from IP version 4 to IP version 6. Okay, so on page 118, they start off with, this kind of sort of a overview. So I have a university, and they have a business school, and they have an Ethernet just for the business school. Then they have an Ethernet just for the engineering, and just for the hospital, and just for the library. And so these are separate networks that inside the network you could just be using layer 2 to get messages across. That's not how it works in the real life, but give me a break. You could, technically, just be using layer 2 Ethernet to get packets from point A to point B. And you wouldn't need anything else. You wouldn't even need IP to do that. Okay, but as soon as I want to talk from the engineering to the library, then Ethernet is not going to cut it. I need something else. That's why we're here. Okay. So, everyone's kind of heard of the idea of an IP address. An IP address is just a number that is assigned to a machine. And you're thinking, wait a minute, don't I remember that from last chapter? Wasn't there a number assigned by the manufacturer to each, network card, that MAC address, that physical address? So isn't that good enough? I mean, why do I need two addressing schemes? Why can't I just you just say, here's a MAC address over here, and here's a MAC address over here. Why do I even need an IP address? Well, the problem is that the MAC addresses you have no control over. You opened up the cardboard box and pulled out the network cards and started sticking them in machines. The numbers assigned to that are not going to be sequential. They're not going to be in any order whatsoever. And, if you had to replace a card or something. So you need an addressing scheme where you have some control. Well, I want that machine to have a number of 12, and I want this one over here to have a number of 42. So you want a number that you can assign. So the concept is kind of sort of similar. It's just that the manufacturers assign MAC addresses, and you get to assign the IP addresses. Okay, let's continue. So, IP addresses are kind of sort of unique in the world. Now, there's an exception to the rule, but bottom line is there's no two machines that should have the same IP address. And I'll put a little asterisk next to that, and we'll talk about an exception a little later on. There is a thing called a network address translation. So, for example, the machines in my network at home are not unique in the world. My machine, this machine I'm looking at right this very second, has a 192.168.0.1. That is not a unique number. My neighbor probably has that number, but we'll deal with that later. We'll come back to that. Okay. So the next on page 119, they have another little goofy little thing here, and let's talk about this in detail because I like this guy. This is a good guy. There's an awful lot of information here, which is pretty cool. So I'm starting at machine A and I'm going to machine B at the other end, but I have to pass through different routers. So here's how it works. So I have the IP address of my destination. Okay, so I want to send it to this web server over here on the edge. That's what I want to do. So the outside container is the Ethernet frame. The inside container is the IP packet, and we'll get into more of that in just a minute. So don't get bogged down in that because I'm trying to explain something. What I'm trying to explain is to get from here to here, you have to use the MAC address. Has to be the destination MAC address is to this intermediate router. It's not the MAC address of this guy, because you can't talk to the MAC address of this guy over here. So I want to send a link. I send the MAC address of this guy, and then when this guy transmits, he sends his destination is the MAC address of this guy, and when this guy transmits, his destination MAC address is the MAC address of this guy, and so on. So the MAC addresses, the destination MAC addresses change for each little segment. Okay, cool. All right. However, the IP address does not change. So the source IP address and the destination, the source being this guy's IP address, the red part. So the web servers, that's the destination IP address, and the source IP address do not change as they go from router to router to router. However, the MAC address does. Okay, so this is kind of an important concept. Let it sink in. Here's a test question for you. How useful is knowing the MAC address of a web server? The answer is practically useless. Why? Because I can't talk to any MAC address who's not on my network. If it's not on my network, I don't care what their MAC address is. This is of no use to me whatsoever because I can't talk to them that way. The only way I can talk to them is talk to my nearest router. That's the only MAC address that I need to know. I don't need to know everybody else's. I just need to know the nearest one to me. Okay, kind of makes sense. Okay. So one more time. On page 120, they talk about why we're using IP addresses. And I kind of sort of told you, so let's just go through it one more time. So MAC addresses are hardware-based, and IP addresses are software-based. So some manufacturer got to pick what that MAC address is right here, and some manufacturer got to pick what the MAC address right here, and I didn't have anything to say about it. So let's talk about one more time. Here's a Trivial Pursuit question. Let's say, for example, the world is poised at the old style IP address, IPv4 is what it's called. And we're going to switch over our network, or we're going to switch over to IPv6. What components need to be swapped out? Do I need to change out this PC? Do that? How about the network card that's in there? My Ethernet card. Do I have to swap out the Ethernet card to make that work? No. Do I need to swap out the little Ethernet card on this side of the router? No. How about on this side of the router? No. Do I have to change the software in the router? Yeah. So the transition from IPv4, and don't get bogged down because we're going to come back to this. But the transition from IPv4 to IPv6 didn't require any hardware at all. It just required software. Okay, let's continue. So there's another little interesting point that this diagram kind of shows. And it's kind of weird because when I start this process, okay, I'm getting ready to send, I want to route to the web server. PC user doesn't really have any responsibility to try to figure out where the hell that thing is, okay? That's not what it does for a living. So the PC has practically no responsibility on performing routing, okay? The only responsibility it has to know where its default router is, okay? You know, if there's a router on your network, which typically there would be, and then every PC has to know where that default router is. That's the only thing they need to know. But they don't need to know that this website is in California and this one's in Arkansas. They don't need to know that at all, okay? So the PCs share practically no responsibility. The routers, on the other hand, that's all they do. And they do need to know. This router needs to know, oh, well, I need to send it to this router over here. Because if it doesn't know that, well, then we're not going to go anywhere. So these routers have to learn the path. It's like looking up a map. I need to get from here to California by car. I need to know, well, I'm going to take this road, then I'm going to change from this intersection. I'm going to switch over to this other highway, then I'm going to change highways here. That's the kind of thing that the routers need to know. But the individual PC does not need to know that. Okay, so could I, for example, well, this thing is probably a box, right? It's probably either one of those commercial grade boxes that cost like less than $100. I got one sitting here on the shelf. And it could be one of those, or it could be something that fits into a 19-inch rack that handles tons and tons of data all over the planet. Or it could actually be an ordinary PC that just so happens to have 2 network cards plugged in it. Okay? I just take an ordinary PC, put 2 network cards in it, and a very small piece of software. We're not talking about a hell of a lot of smarts here. Just a couple pieces of software that you can get for nothing, and you can turn a spare PC into a router with no trouble at all. Okay. So these aren't magical boxes. They could be just PCs that you have laying around. You can make your own router if you wanted to. Okay. So now we're going to be talking a little bit more about the IP protocol itself. So on page 120, there was the way the internet community works is they do requests for comments or requests for proposals. And an RFC is a request for comments, which means I'm getting ready to come up with a new protocol, and I want to send it out to the world and have everyone have an opportunity to kind of chew on it and make comments on it. So request for comments is the way this thing works. There's a problem with the whole concept of requests for comments because there's not an overarching governing body per se. There's not someone in charge. Anyone, me, I could submit for a new protocol. I could go in and say, I want to do a request for comments for a brand new protocol that I invented. Okay, I could do that. Okay. Now, there's problems with that. One is this takes a very long time. It's basically kind of consensus oriented. You have to work out all the issues and make it all work, right? So it takes an awful lot of time. And the other problem is these things, or what a lot of people call perpetual drafts. They're perpetual betas. They just, here's a beta version and we just keep, and it never seems to kind of solidify. People just keep asking more questions and more questions, and this just stretches out, it takes years and years and years. Okay, this is a good place to stop for the 15-minute mark. We'll pick this up again in just a few.